Hi, everybody. My name is Jessica White, and I am Managing Editor at Supply Chain Brain. I want to welcome you to today's webinar presentation on AI-driven best practices in the warehouse, presented by Lucas Systems. Today's presentation will be recorded, so it will be available for you after the show. I also want to remind the audience that there will be a Q&A after the end of the presentation, so I encourage you to submit your questions at any time throughout the webinar. You could use that little Q&A button at the bottom of your screen. Now, warehouse work has been transforming at an amazing rate over the past few years as operators look for new and innovative ways to boost productivity and accuracy. So today we're going to hear from an expert on distribution center design and strategy who will give us a clear understanding of techniques to increase throughput and optimize your workforce. Before I introduce our speaker, let me tell you a little bit about Lucas Systems. The company was founded in 1998 as an innovative voice-directed solution provider. They were actually first to deliver voice solutions on open platforms and multimodal devices, and also first to deliver voice apps on Android devices, including smartphones and smartwatches. Over the past 5 years, Lucas's focus has been on software solutions for on-the-floor process optimization. With that, I want to introduce Dan Keller. He is Senior Solution Consultant at Lucas. Dan has over 35 years of experience helping businesses implement distribution technologies for retail, healthcare, industrial manufacturing, and much more. To say the least, Dan understands the unique challenges faced by warehouse managers today and what they need to ensure top performance. Dan, thank you so much for joining me today, and I will go ahead and turn it over to you.
Thank you so much, Jess, and welcome everybody. In today's webinar, we'll introduce you to some ideas on how to use technology to elevate associate job satisfaction and to optimize your on-the-floor processes. So, the big problem everybody's facing: not enough qualified warehouse workers to maintain adequate service levels. You know, everybody is facing the same problem. Can't hire enough people. So let's think about or talk about some solutions to that. Well, here are four, no, not really, three ideas, okay? Increase worker retention by making the job easier to do and easier to learn. Optimize your processes to get better throughput with your existing workload and your existing workforce. And then add automation to reduce your labor requirements further. That is the subject of today's webinar. Interestingly enough, recently, Lucas surveyed with Wakefield Research 500 warehouse workers across the United States. Here's Don to tell us a little bit about what we learned.
There's been a lot of talk about attracting and retaining warehouse workers, but not so much from the perspective of the on-floor warehouse workers themselves.
As a pioneer in warehouse technology and solutions that help warehouse workers do their job better, Lucas has developed the Voice of the Warehouse Worker Insights. We surveyed 500 on-floor warehouse workers across the U.S. with the goal of directly capturing the warehouse worker's voice and delivering actionable insights to warehouse and DC leadership.
Here's a glimpse of what they had to say. Labor shortages have been an issue for a very long time. However, what we found is the majority of warehouse workers want to keep their job and do it very well. However, 3/4 of the workers surveyed said they are likely to take a slight pay cut at another company that has more technology for them to work with.
But workers want relief from the physical and mental strains of working in the warehouse. This might not be shocking, but what is a surprise is how on-floor workers see technology as a critical solution and highly value the impact technology has on transforming their work experience. But what kind of tech do workers say they want? They want tech that will help them be more productive and accurate. That includes robotics, with 75% of workers being excited by the idea of working with robots, if it's done right.
Find out more about how the warehouse worker feels, what they believe, what they fear, and what they hope for. Get deeper insights on managing your workforce with Lucas Systems, Voice of the Warehouse Worker.
Visit lucasware.com/voice of the warehouse worker to download the Voice of the Warehouse Worker insights.
Interesting. So what are we going to do? We're going to try to make the job easier to do and learn with voice so that those people are happier and stay longer. Voice-directed applications, which incorporate complementary technologies like barcode scanning, visual cues on screen, and connected like lights, have proven to be the most effective method to train and retain hourly employees. Unlike lights, the same technology and methodology can be applied across multiple DC processes, not just picking, but also order consolidation, sorting, inbound handling like receiving and put away, pick bin replenishment, cycle counting, and truck loading. Some examples of applying intelligent voice-based applications to warehouse processes. When you can make a warehouse associate's job easier to quote unquote get it right, they have higher job satisfaction and tend to stay longer. This is a good example of this exact idea. So this is about the Sportsman's Guide, an e-tailer in St. Paul, Minnesota. Here's their story.
Sportsman's Guide is an e-retailer, so we service all the hunter and fishermen in the United States, camping, anything for the outdoors. My name is Jason Plum. I oversee warehouse operations at the Sportsman's Guide. Yeah, the Sportsman's Guide has been around for over 40 years. So we started off as a catalog company where we were sending literally millions of catalogs out on a weekly basis. You know, years ago, we made the shift over to be more of an online retailer. So our catalog business has dropped down significantly, but most majority of our business, it's in the high 80%. Is coming via the web now. So we've seen a nice business growth. Obviously, a lot of online retailers seen a significant boost in business, and we can see that business continuing to grow over the next few years.
My name is Jerry Marcotte. I am the outbound supervisor in charge of picking, packing, and shipping. So this warehouse is roughly 330,000 square feet of racking space.
347.
Pick 1.
Grab 1.
9 Alpha. Put 1.
354 for 1.
We have typically around 30,000 plus SKUs.
At HQ, we're doing on average about 8,000 orders a day. So there's about 1.5 pieces per order. So we're up over that 12,000 pieces a day. And that's during this time of the year. Coming into peak season, we're gonna about 2.5 times that volume out of this facility. The biggest vision for the Sportsman's Guide is we wanna be fast to the customer, and then we wanna be accurate, right? You know, so if you walk around the DC here, you're gonna see a lot of signage that says, "It's a satisfied customer with every package," and that's our motto. So Jennifer helped us meet these expectations by increasing our productivity. So when we launched with Jennifer, we've seen an 18% in productivity gain. And then also we've seen a nice increase in our accuracy.
Jennifer does everything for us but reach out and grab the product. She sends us to the locations, tells us where to grab from, how many to grab, where to put it on our cart. She won't let you make a mistake. If you're at the wrong location, she will tell you invalid.
I love work with Jennifer because it's more easy, because she told me everything I had to do every day.
So much nicer because you don't have to mess around with anything. She tells you where to go, what to do, and it's much simpler.
199,
199, invalid 6, 38, 11.
198, 3.
Pick 3, put 7, alpha.
When you're bringing in seasonal associates, it's that training that needs to occur, right? So with the increase in productivity, we've seen a decrease in our training labor, which has helped significantly.
It should only take a few hours. Some people take a whole day. Some people need extra help. It just depends on the person. Some people will learn in 2 hours and get it going right away.
Where we're seeing a nicer jump in accuracy was actually from the seasonal staff. So the seasonal staff was running about 98%, 98.9% accuracy. And then once we got them trained on the Lucas system, that went up to about 99.5.
I cannot imagine going back to the old way we used to do things, picking by visual paper.
We built our application together around our process. And that's one of the reasons why we went with Lucas.
It's better with Jennifer.
Okay. I think that's a good story because in essence, again, very important to them with a lot of seasonality to get those seasonal workers up and running quickly. So we've learned from our past few minutes that there is good ways to utilize some technology like what Lucas has to make it easier, to make the tasks easier to learn and do. The next step is to use AI and smart software to optimize the process. Okay, the first place to look for this is in smart batching and in smart pick paths. This opportunity to move from one trip to one task per trip to batching is very important. Now, I would hope that most of you who are doing small orders or many, single line orders are already batching your work in some manner. So picking multiple orders in one trip to the warehouse. In a direct to consumer process, you absolutely have to do that because, the travel will just kill you otherwise. You may be using a pick cart that looks like this. This is an example of one of my customers who's got, I think they do like 32 orders at a time. And again, small, fill it in there and then bring it to the backing stations. But not just batching, but smart batching is what makes the difference. So Lucas uses AI-based something called dynamic work optimization, which combines smart batching with pick path reduction to provide game-changing productivity gains. The smart batching software also takes into account order priority, so you can achieve the right balance between pick density, yielding the highest productivity, with making sure that you will still make your gate times for orders which may have come in late, but absolutely must be shipped today. Smart batching has been shown to cut 20 to 30% of travel time in a process like we've just illustrated. Here's Kyle to tell us a little bit about how dynamic work optimization actually works.
Consider the following warehouse map and visual pick list. The blue dots are individual picks for a single order, all of which need to be picked by our RF user there next to the start. Now we see their pick path as dictated by a WMS-driven pick sequence, in this instance, Serpentine. The user will traverse each aisle that has picks in it, and in most cases, traveling the entire length of the aisle. In this example, they would have traveled about 934 feet. Let's look at the path that is generated using our pick path optimization engine. It uses a number of traveling salesman mathematical algorithms, crunching travel costs across a digital map of the warehouse. Now we see that we have significantly reduced travel time for our user. Instead of picking those picks at the bottom of our map in aisle sequence, we save a ton of walking by grabbing those at the very end. This results in an estimated savings of 18% for this order. All of this extra travel is eliminated. Now, many of us have seen really sharp pickers in action, ones that can find workarounds or shortcuts that shorten this distance. But what about your newer pickers or your temporary force that you just brought in? Our engine helps to democratize these shortcuts, in addition to making our fastest pickers even better. Now that we can use math to help us build efficient routes, and now that we know which orders can be picked based on priority, let's look at the third component, intelligent batching. One of the key ways that warehouses can save on travel time is by batching orders. We now see a group of the next available orders in the system overlaid on our map. So we first see the pick path generated by our engine to pick order number 1, the highest priority in the system, traveling a distance of 432 feet. Most warehouses batch in a first in, first out manner. So the user will be assigned order number 2 to pick with order number 1 in their batch. Picking both together results in a total travel of 704 feet, much shorter than if they had picked them separately. However, there is a better way. Lucas's AI-based tools look at the pick path of all available orders in the system to help determine what an optimal batch is. Looking at the map, which order matches really well with our current pick path? If you noticed, order 6 in green almost matches our pick path perfectly and will make a great addition to our batch. We see only a small amount of additional travel is needed to complete both orders, resulting in 456 feet of travel to pick both orders. Consider how much greater the benefits could be once we pick batches of 4, 8, or even 20 orders.
Okay. So, AI-based optimization can make huge differences in terms of the pick path and in terms of smart batching. So now we're going to show you a story from a customer who's actually using this in their e-com area. So as you listen to this case study, focus on what he says specifically about e-com. Here's the Southwire story.
My name is Chuck Jones. I'm Director of Distribution Modernization for Southwire Company.
Southwire is one of North America's largest manufacturers in wire and cable. We also sell tools and assembled products.
We have a 30-plus plant network where we produce wire and cable, and we also have a 10 distribution center network where we distribute those products as well. We have a retail customer base. We also sell through the energy sector to help modernize our distribution network. The first area that we look to from a modernization standpoint has been our investment with Lucas Systems. We've invested and implemented the system at 4 different sites. And we've seen some pretty good benefits as a result of the system.
Before we were using Lucas, it's very, very manual. When we transitioned to Lucas, it sped our picking up tremendously. Day-to-day picking on SAP would be, picker would have a scanner and a tablet. They'd have to read the tablet to know what location to go to and have to scan the product, read the tablet again to see how much material they're supposed to pick for what order. Current operation with Lucas, we have a handheld device with a headset. You don't even have to look at your handheld device. You don't have to read anything. Put your headset on, keep your handheld device close. Jennifer tells you everything you need to know.
Lucas makes it to where we can fix things as we're going, and it's easier to pick and understand how many cartons and how many eaches. She explains it very well. 5, 4, 2, 8. Pick 8.
It was a very smooth transition. One thing that Lucas did help with is training. Training time for picking reduced tremendously.
Originally, we didn't have any logic that was backing how those batches are built. It was literally just picking the highest priority deliveries and putting those in a batch together. But Lucas has given us the capability to really optimize how those batches are built. The advanced technology basically takes all the assignments within a certain date range and minimizes the travel time for a particular picker based on the batch of work that's assigned. So essentially it's going to overlap like SKUs to that location. Ideally, you're going to have to go there once for multiple orders versus different trips. So
Lucas plans our pick path for us, so it probably saves me two and a half hours a day.
I think the Lucas AI was pretty important. It's definitely optimizes how work is done, and that was a big driver in the cost justification of being able to invest in a system like this. Safety's been a huge benefit as well, just having the users be kind of hands-free, eyes-free now that when they're driving their lifts around. Previously, they're having to stare at a tablet to get the relevant information, to know where to travel and what to pick. The biggest driver for all these projects really has to do with productivity. There was a lot of skepticism about changing our picking system again, but over the course of a couple of weeks, they eventually adapted to it and accepted it pretty well. From a supervisor and lead standpoint, they loved it from the beginning.
First time using the supervisor dashboard, it was easy to pick up. Pre-Lucas is very manual. You had to pull reports. Most of my reports have went away since Lucas.
The Lucas Management Console helps me, manage productivity by, priority orders, what needs to go out. We have a variety of orders that are hot throughout the day, so just managing priority, making sure that they're all available to pick in Lucas.
We knew going into the project that we'd see productivity gains. That was obviously the hope, but the amount that we saw in our .com picking area has just been outrageous.
Okay, so we've made it really easy for associates to learn and do their jobs. And we've applied as much smart software to make the tasks as efficient as we possibly can. So you've heard all about that from these two case studies. What's the next step? Okay, so you've heard a lot about robots. The next level is to take the mundane tasks, which people may still be doing, like moving pick carts or running pallets, and let machines do these tasks. Where you have the opportunity to further reduce travel time for units of work to go from one place to another, you can look at the new breed of AMRs to accomplish these tasks. There are a number of companies now offering various flavors of autonomous mobile robots, almost all positioned to be collaborative with your human workforce. You'll still need optimization software to coordinate the collaboration of the AMRs with your human workforce. Let's hear from Ron, who will illustrate the coordination and orchestration of robots and people.
In our final example, we're going to apply digital automation to optimize and coordinate the work of humans and robots, orchestration, if you will. This coordination will be handled by our DWO, or Dynamic Work Optimization module. Currently, the robots or AMR company's solution is to have human workers read a robot screen to know where their next action is. But in our example, the pickers will receive their instruction through headset and use voice or scanning or screens to actually confirm the picks. So we're kind of decoupling having to read the screen on the robot from being able to direct and move the pickers or the human labor around. Adding coordination and communication between robots and people will provide significant value in reducing travel and will also result in better positioning of the resources, both robots and humans. Before I start, I will again mention additional advantages of dynamic work optimization, which is the real-time batching of orders. That feature is not represented in this simulation, but could be added to the overall solution. So here a picker is directed to pick location and robot A. Once the first pick is completed, the system takes into consideration the location of the picker as well as the location of all the picks and the corresponding robots. The system directs the picker to the location directly behind them and coordinates moving the correct robot to that location, and also positions robots for future picks. Once that pick is completed, the system directs the picker and the robot to the next pick location. As you see here, the picker is directed to the pick in the next aisle instead of the robot that they could see in the current aisle, which is the current solution envisioned by the current generation of robotics. If the system detects sufficient demand, or if labor becomes available, a new worker, the little dot at the top of the screen, may be directed into the zone. As picker 1 is completing the pick to robot C to provide a more efficient pick path and distribute work among available pickers, the system has determined that robot B should be repositioned. And the second picker gets directed to robot C. Picker 1 and 2 continue to get instructions and complete their picks. Because they're directed, they don't have to scan into each robot before they pick, which is, again, the current practice. They can confirm placing the items to the correct robot or tote by speaking a check string or scanning or using RFID. And we now watch them complete their picks. As picker 1 completes the pick to robot B, they can be directed to another area of the warehouse, again based on the demand, because now there's not enough pick density to support 2 pickers in this area. In summary, this slide shows the path with human-robot coordinated picking, showing travel of a total of 202 feet with an over 50% reduction in human travel. And this slide shows the 2 pick paths, kind of the before and after overlaid.
Okay, so to summarize, 3 levels of optimization opportunity to explore. Make the tasks easy to do and easy to learn using voice-directed applications. Optimized units of work using smart batching and smart pick path, AI-based solutions. And then add AMRs along with your optimization and orchestration software to maximize your worker productivity. Okay. Back to you, Jess.
Thanks, Dan, for such an informative overview of these important topics. We'll move now to our audience question and answer portion of the webinar. And even as we're answering these questions, if you come up with more, go ahead and continue to enter them into that Q&A chat at the bottom of your screen. Okay, so first question here. If I had voice picking, is the technology for AMR already embedded, or is it a whole other technology layer?
Okay, good question. Just because you have voice picking does not imply that you have the AI-based software as part of that. I can only speak for what Lucas provides it from my experience today, but when we provide our solutions, there is an option depending on the warehouse setup to provide the additional AI-based optimization. And usually it makes sense to do that because when we do assignment creation, when we do unit of work creation, we look at opportunities to, again, reduce pick path, reduce do smart batching. So I have to say that from my understanding, Lucas is probably the only company that provides both the optimization, AI-based smart batching, pick path, and the voice directed.
Okay, so our next question here is a little bit of a small series. How does the assignment building process work, and how long does it take? Is this something that is done at the start of a workday or several times during the day?
That is a really excellent question. Most WMSs and systems that do this create units of work when the work shows up on the system that that you're going to be using. So, for instance, when you drop a wave or when you drop your work. But Lucas's dynamic work optimization doesn't work that way. And one of the words in there is dynamic. So that implies, and actually the way our system works, is that the actual final unit of work, that smart batch, is created in a just-in-time manner. It actually creates itself exactly when the user says, "Give me work." And it does that by looking at all the available work at that exact moment, using its smart AI-based algorithms to then combine them. And that's also based on the equipment that the user is using. So for instance, if he's got a cart that he's using and the cart has certain characteristics, either linear on, I've got 3 shelves, each shelf is so long, I can, I know what kind of cartons I can fit on it. So then the system is smart enough to go out and figure out, based on that, how many orders and which orders can I put onto that cart. The same is true if you're picking cases to a pallet. We've actually begun to apply this in the grocery business, where most units of work are 2 or 3 pallets worth of work. So in essence, by making a last minute decision to which pallets to place onto your long forks or your jack can make dramatic differences in the travel time. We just did a project, or actually simulation, which we're leading into a project for, and we showed that we could actually reduce travel time in a grocery large operation by over 20%. It's gigantic.
Wow, that's impressive. Okay, these are great questions coming in. We have a lot of them to get to still. How do you handle increases for seasonally larger orders?
Well, so the size of the order actually is taken into account by the AI-based algorithms, because what it's looking at is actually how many line items and number of stops that each one has. So, okay, that doesn't work. Excuse me. Sorry, somebody was calling me on Teams. So even if you have a large order, which might have 20 or 30 line items, and you have other small orders that might have 2 or 3 line items, the system takes that into account when it's calculating its units of travel. And that's how the AI works, is that there are units of travel based on the warehouse map, and it calculates out the total time it's going to take to do each of these stops, and then puts them together and figures out what's the most efficient way to do it. So I guess the answer is it's as long as you're going to make your gate times. Now, you might have situations where a large order comes in and it'll take so much more time to do that some small order, it takes more time because, I got a 2-line order and then I got a 50-line order. Well, if I put those together, I have to pick all 50 or lines that one order to complete it. So when we do our configurations, we take that into account. Now, again, there's prioritization and there's gate times. So if that 2-line order has to be at the packing station within 10 minutes, I won't batch it with that 50-line order. The AI is smart enough to know, that won't make the prioritization. So it puts it in another batch. Okay.
Okay. So with a WMS, how does the AI work with waves generated in the WMS?
So that's a good question also, because waves are an important piece. When we configure the AI, we look at the waves. Now, waves, as most of you know, have different purposes. So for instance, in some cases, a wave represents how many loading doors you might have available at any time. So you basically create a unit of orders or assignments or work based on how much you can put on the dock and then subsequently get into the truck at one time. You know, you wouldn't want to be picking an order along that you know, the truck is not going to arrive at the door for 2 hours because you have to have a place to stage it. Other systems are generating waves for different reasons. They might be based on replenishment cycles. In other words, how much have I got in the slot and how much time is it going to take me then to make sure that I have enough product so that I don't send people to get that product and it's going to be out. So the answer to the question is the AI-based algorithms are configurable to be able to go beyond priority or wave where it makes sense. So, you know, again, it really depends on how you interpret or what a wave means to you in your system, but it can cross it. So for instance, we just did a project with a very large e-tailer, very common name, I can't name it, but where the difference between using the Lucas AI and their sophisticated tier 1 WMS batching methodology was the ability to both cross zones and waves within the same unit of work. That made a profound difference to this customer. That's why they chose our solution.
Okay, so there's kind of a part 2 to this question from the same audience member. How does the AI interact with external tools to the WMS, like AGVs, for example?
Well, that's interesting. So there's a great deal of coordination involved. Our software doesn't drive the robot. The robotics companies drives the AMR. Our software will come up with creating the optimal unit of work based on travel, because we are respecting the fact that we want the robot also to travel less. And we then are instructing the robot based on that, where to park itself. There are areas of the warehouse. We send that information to the AMR. We then coordinate the labor to be able to direct them to the pick areas, which they then are doing to the robot. So it's a fine dance, as they say, to make sure it all works together. Pretty new, I'll tell you, it is pretty new.
Lots of moving parts there.
Yeah.
The service of using IoT and cloud-based operations in warehouses, would that be classified as software as a service or platform as a service or even infrastructure as a service?
Not sure how to answer that. I kind of differentiate them. IoT to me is the setup of lots and lots of feeds of information coming in from various software things, people, et cetera, all to be able to go into an inference engine in an AI-based environment. How you pay for it or how you license it is more the SaaS or that. So I don't know if I can answer that fully yet. I can tell you that the things that we've been doing on the software side are available in SaaS environments where we have the servers off premise or in server farms. That's not been a problem or an issue. I don't know enough about the PLC controllers or the things that are part of the IoT to be able to answer that fairly. So I'm doing the best I can.
Okay, we'll move on then. With a robotic and voice dual solution, would the pick transaction be confirmed or completed via voice, or is the picker just directed to the robot via voice and then completes the pick on the robot tablet?
No, the system of record for the pick is the voice system. So all of the confirmations are done in the voice system, which then feeds that directly back and forth with the WMS. So the WMS still gets a real-time feed on what's going on. The robot becomes basically the appliance to the picker to the picking process. So basically we're, as we're picking, all that happening in real time and transacting with the WMS, the robot is at some point, our system is giving direction to the robot, like says, okay, I'm done with all the picks that I need at this particular node in the warehouse, move. Okay.
Okay, so here we have kind of a follow-up to some of the case studies that you told us about today. How can a given DC get an idea for what kind of savings they might see from the tool?
Great. Okay, so there's a couple of different steps in there, but that's something that we do a lot. When we assess an opportunity that's going to involve AI and optimization, the first thing that we do is we send at least one or more of our experienced consultants out to the site or sites, and we understand the workflows and the current environment. What's the WMS? What are they currently doing? How many pickers? What are the pain points? Then, if we determine that they're eligible for the optimization AI-based engines, we will, depending on the size of the business, we will then engage with them on a simulation. We'll gather data from their current systems, which tells us about their current pick times and pick processes. We'll get a warehouse map from them and we'll embed that into our engine. And we'll actually run a comparison between using the AI tools that we have and their current process and make a determination what the potential gains will be with the AI engine. Now, again, that I can't do that for a guy with 3 pickers. That doesn't work. But that's why we'll do an assessment first to make sure that you're really eligible for something like this. I'll tell you, and the question hasn't come out, but I can tell you, generally we look for opportunities where there's at least 10 to 15 pickers or more, and where the warehouse has a substantial enough size or enough slots. Like you may be a 30,000 square foot warehouse, but you sell jewelry, so you've got 50,000 items. So I won't just qualify it by size, but it has to be a substantial enough amount of stops in your process and people in it to make sense.
That's good to know. Kind of a good transition as well to this next question about picking. So what if the company isn't batch picking? Can the software still be used for pick path optimization?
So I'd want to first understand why you're not batch picking. Maybe your orders are so big that it doesn't fit. I don't know that. But yes, the answer is you can still look at pick path optimization even if you're not batching. We typically will, again, when we do an assessment, once we've talked to the people about it and gone out, you go out to the site, you find out what's going on. Maybe there's opportunities to do some batching and not all. But pick path optimization is certainly something we can do. In fact, funny story, the first place we did pick path optimization, it was a pretty well-known company that supplies parts in the outdoor equipment market. And they swore that they were doing things absolutely right and their pick path was right and it was perfect. So when we started to apply the AI-based tools to it, their supervisor went out with one of these little wheels, what the thing they put on a stick with wheels that actually measures the linear feet. And he walked the pick path himself. He said, this is how far it's going to be. And we actually showed him that we could save him in, I think it was about 25% of the travel. And he was just amazed.
Wow, that's amazing. I've never witnessed that one before.
Oh, yeah. Oh, yeah.
Okay, so we have a few more questions to get to here. When it comes to inventory, how can AI-based optimization help optimize inventory or in slotting operations?
Okay. Interesting. I will answer that. I'll answer that as a 2-part question. So inventory-wise, our optimization is strictly for the execution. We are not doing the things that a WMS does for instance, pick bin sizing. We're not looking at economic order quantities or any of that. Certainly, the first piece of my seminar we talked about, which was the making things easier. We want accuracy to be high. So having high accuracy in your process will make your inventory more accurate. But for as far as the optimization goes, I don't know that we're really taking into account optimizing your inventory sizing, how much do you put into your pick slots and things like that. So I'd have to say probably not on that side. On the slotting side, it may be a little bit different. There are opportunities to utilize some of the AI-based tools that we have to actually get, we have a byproduct called our slot recommender, which basically is I call it the easy button of slotting. Most slotting software packages, and there's some very good ones out there, require a lot of input and a lot of time put in to get it right. What we're doing is since we've already got a warehouse map, since we already know where we're picking product from on a regular basis, and we're gathering all that data, we've created a tool that allows you to basically get a quick and dirty slot recommender. Basically, if you move these 10 items, the payback could be really good. And we even show some of the potential return on investment by doing it. And it's very simple. It doesn't do all the execution of it, but it basically is a simple tool. And so there are opportunities using the AI-based engine to derive some smart slot moves that will help you to get better return.
Okay, so this next one gets down to the nitty gritty here. Does a system like this, like Lucas's, integrate easily with a WMS or ERP, or is it an expensive and complicated process?
Well, the word expensive is a subjective question. So we've integrated with just about every WMS and ERP that I can think of out there, Oracle, SAP, all the Infors, Manhattan, Red Prairie, or I'm sorry, Blue Yonder, whatever the color of the day is. So we've seen all of those. The integration of it is data. So there's data being sent back and forth. And it takes some hours to do, but it's not rocket science. This is not going to take you, tens of thousands of man hours to do. Most of the projects that we see are 100 to 150 IT man hours to do a really good integration. What was the other part of the question?
Is it expensive and complicated?
Expensive.
And does it integrate easily with an ERP as well as a WMS?
Yes. So yes, we have lots of customers with ERPs, and it integrates fine with those. Like I say, expensive. There is some cost, and the cost we do is based on figuring out what the hours are, but not just for the integration, it's for the entire workflow configuration. And I will tell you that the vast majority of projects that we have been doing over the past 3-4 years, the ROI, the payback, the crossover on the project is less than 12 months. So expensive. If I told you to, if you put $10,000 down today and you'll have it back in a year, and in 5 years you'll have $50,000, that's pretty good.
Sounds good to me. So this next one is really good. In your opinion, so we talked a lot about a lot of different areas where AI can help, but in your opinion, what are the best and most easily implemented areas in the DC where using AI-based software can make an impact?
Well, again, we did talk about it. I think on the pick optimization side, where you're doing batching, where you have enough opportunity to put several orders or pieces of orders together and come up with more efficient units of work, which our AI-based engine is really, really good at. That's the place where I think you've got the lowest hanging fruit. And like I said, we've proven this even in environments where you might be doing 20 or 30 orders or parts of orders at a time, even in a grocery where you're doing only 2 units of work, one on each pallet. but you've got a large enough footprint to justify it. There's a combination. If you're doing 2 units of work at a time or 2 orders and your warehouse is only 20,000 square feet, well, how much can I save you? So that's where in that environment, first, of course, in picking, you also got the most labor usually. So you've got the most cost in terms of people. So those are the areas where I see it the most. You can also apply AI to other things like figuring out what to do in terms of, for instance, we're looking at it from an audit perspective. One of our modules that we provide a lot of our customers is a statistical based audit, which allows you to check, but not everything, certain criteria, certain customers or, pickers or products that might be areas where you feel that there might be risk. And so applying AI to that particular area says, well, based on all the stuff I've done, where should I turn up or gear up my audit or gear it down that's going to make the most impact on my accuracy out to the customer? So that we think is a good area. We're looking at that also.
Okay, so this next one asks a little bit about other WMSs out there or various WMS options. As we are looking at WMS options, many of the suppliers are telling us that optimization is part of the WMS. Is this true? And what is the difference in the Lucas system or the Lucas optimization from what I would get in a WMS?
Okay, and that is a very good question because it is a point of confusion out there. Optimization is a byword that everybody's using today. So it's a matter of figuring out what optimization does that really mean. We've looked at, and our customers have looked at almost all the WMSs that are out there. And the way that we approach optimization with the AI-based smart batching and smart pick path, I have not seen that combination being done in WMSs with, remember that first word, that dynamic word, in that real-time, just-in-time process. That's one of the big differences. Most WMSs, they're smart enough to be able to figure out, yeah, I'll create these batches of work right now when the order comes down, and then that'll sit there for a couple of hours or 20 minutes, depending on when it's going to be executed. The problem with that is I just got an order 5 minutes ago. It came in. I have to ship it today. And it matches exactly the pick lines that I'm going to be doing in a minute, but my batching doesn't take into account the dynamic part of it. So you miss that whole piece of it. So the dynamic piece of it is something that's kind of unique in terms of how we approach it. So I wrote an article I can send anybody a link to, in fact, about whether it makes sense to replace your WMS or to look at optimization bolt-ons. So be happy to share that with anybody who'd like.
Oh, perfect. So it looks like we have time for maybe one more question here. I think this is a good one to end on, and you touched on it a bit earlier, but maybe you can expand a little. How much time would it take to implement an optimization solution?
Okay, yeah, that's a good one. There's a lot of pieces to it, but it's not nearly as complex as implementing a full ERP or WMS. So typically these projects require, I'm going to say, about 4 to 6 months to do a really good job on. You've got time that you need to spend in terms of getting on the warehouse floor, understanding and configuring all the workflows, and then getting the warehouse map set up. So there's time in preparation, as well as the software configuration and testing. So typically our projects at Lucas are about a 4-month duration from the beginning to when you actually go live. And it could be a little longer or a little less depending on your situation.
Okay, great. Well, Dan, I want to thank you and Lucas Systems so much for such a great presentation today. And I want to thank our audience for listening in and asking some really great questions. So on your screen, you're going to see an email address where you can reach out to Dan and schedule a consultation. Go ahead and take that down, or don't worry, we'll be sending it out to you as well after the webinar. And you can schedule that whenever it works best for you. Again, thank you so much, everyone, and I hope you have a wonderful rest of your day.
Hope you learned a lot and enjoyed it, and hope to see you and talk to you soon. Thanks, everybody.
Thanks.